Okay, so we'll consider the this example where a system has five processes like P0 to P4. So if you see this P0 to P4, and there are resource types A, B, and C. Okay, so resource A has 10 instances. Means if you consider resource A as any like a printer or a scanner or maybe a keyboard or maybe whatever, maybe a server. So if maybe a magnetic tape or maybe a hard disk, or whatever resource. So that's why resource in general A, B, C we have given. Then there are 10 instances. Means 10 you can allocate 10 instances of resource A to your processes. Okay. In the same way, B resource has 5 instances. Then C has 7 instances. So totally 10, 5, and 7 instances are available. Then at a time t naught, the snapshot is taken from that system. So what is the snapshot? So processes P naught, P1 to P4 as given. Then what are the allocated resources? Allocated resources are A, B, C. So initially P naught is already allocated with 0th A, 1 B, and 0th C resources. So in the same way, all the processes are allocated. Then maximum resources for P naught is 7. Okay, so it needs maximum 7 resources, but it has only allocated how much? 0. Okay, so it needs maximum how much? 5, but it is allocated only 1. Then it needs 3, but it has allocated only 0. Okay, so how much is the available resources? So available resource sometimes they will give, or maybe we need to find out. So how available resources? So if you observe, C 2 plus 1 plus 1. So how much? 5. Okay. So how much is the maximum resources available is 7. Okay. So if you take at the end here, uh, so how much? So how much is if you add everything? It is 3 plus 2 is 7. Then here it is 2. Then here it is 5. So this is already allocated. So maximum available for A is 10. So 10 minus 7 is 3. Okay. So B is maximum 5, but how much allocated? 2. So available is 3. Then C is 2 plus 1 plus 2 is 5, but available is 7. So 7 minus 5 is 2. So this much is available. So so the system snapshot is at the random point at time naught t0. So if it is not given, you can calculate by using this. Okay, so allocation at this. So this much is available now. Okay, so first what we need to do is before going to that safety algorithm, we should first check the need. So first step is we need to find the need matrix. So how much is the need? Need how we can calculate is maximum minus allocated, because we need 7 but allocated only 0. How much I need is 743. So how to calculate? 753 means 7 minus 0 is 7. Okay, so 5 minus 1 is 4. So 3 minus 0 is 3. So in the same way we will calculate the need matrix of all the processes. So P0 I have done. So P1, if you observe 3 minus 2 is 1. Okay, so 2 minus 0, it is 2. Okay, so it is also 2 minus 0. So we need to find the need matrix for all the process. That is the first step. Okay, so after finding the need matrix, now I have to apply the algorithm, that is safety algorithm. So we will apply. So find the safe sequence. Okay, so what is the initialization? Initialization is what is the work. If you observe that first algorithm, the work is nothing but available. How much is available is 332. Okay, so then finish off that I. So I, how many processes? There are 5 processes. So all the processes are initialized with false. So available is this, then initialization is this. Then we will take one process at a time. So first one is 0th process. So how much need of that process? If you go to the need matrix there is 743. So 743 is the need. So we'll take P naught 743. Then how much is available is 332. Then for need not, so need zeroth process is it less than or equals to work? That is the first case of our safety algorithm. So if that need, if need is less than work, then you allocate. If it is not, then you should go to again step 2 and continue with the next process. Okay, so need 743 is less than 332. How to compare? So every resource has to be less than that resource type. So 7 like A, so A, B and C here available is also A, B and C. So 7 is less than 3. No, the first condition itself is false. So we cannot allocate. So we cannot allocate this process. So P naught must wait because it is not in the safety sequence. Means right now I cannot allocate. Okay, so I will go back to next process and I will come back to that P naught process. Then going on with the next one, the next process is P1. So how much is the need is 1, 2 and 2. Then available is, yes, 332 is available. That was the initial available of our initialized resources. Then need 1 is less than work. So need is 1, 2, 2 less than 3. Yes, 1 is less than 3, 2 is less than 3, then 2 is less than or equals to 2. So at least less than or equals to. Yes, this condition is satisfied. Now P1 is added to the safety sequence. So safety sequence is P1. Okay, so how much is the available now? So if you observe our banking algorithm where we will allow available is now updated. So available is nothing but available minus request, but you make it very simple where so available was initially 332. So how much is allocated for that process? So if you observe the allocation is 200. So simply you just add them. So available is now 332 plus 200 because after executing the process after executing the allocated resource should be given as available because those resources are not needed for that process. So how much is allocated for process 1 in the initial? It is 200. Now it doesn't need those resources because they are P1 is executed, so it is releasing these resources. Which were it is releasing? The allocated resources it will release. So it is updated into now they become available. So how? So available initially it was 332, then it is now added. So P1's allocated resources are now added. So just add 3 plus 2 is 5, 3 plus 0 is 3, then 2 plus 0 is 2. So now this is our updated available resources. So updated now becomes 5, 3 and 2 and our finish means if you see the safety algorithm, now finish of that process is true, then go back to again step 2. So what would happen is we should go back to the next process. So next process here is the second. So second process it needs 600, then available now is 532. So again you just check with the need. So it is not true because 6 is less than 5. No, we cannot allocate. So hence P2 must wait. So safety sequence is only 1. And our finish is not updated. Only first process is executed. Hence it is only true. So we'll go to the third process and we'll see how much is allocated is 122. Then 532 because available is not updated. The need of third process is less than work. Yes, available is 532. Then check. So 0 is less than or equals to 1 is less than or equals to 3, 2. Yes, we can allocate now. So P3 is now added to the safety sequence. Now see P1. After that you can allocate P3. So now if it is allocated means executed, now we here need to update this available. So how much available? So available plus allocated of P3. So if you observe allocated of P3 is 211. So just add 211. So 532 is now updated to 743. it is updated to 743. So now again the finish is updated. So the third process is true because it has been executed. Then the fourth process again, the loop will continue till the end of those processes. So need is 011, but available is 743. Yes, true. Then safe sequence added P1, P3, and P4. Then available 002. Just add the available allocated resources to available. So it is updated to 745. Then update your finish. So fourth process is also finished. Now, if you observe, we have actually end of the loop means we have checked with all the processes, but we should go back to step 2 because there is a condition. If no such I exists, no such I means all the processes should finish because there are some processes which are still they are at the false where means they have not finished. Those processes are nothing but P0 and P1. So after completing the fourth, we should again go back to which one? P0 because our available resources are now updated, or maybe we can check now whether uh, that need is satisfied or not. Again, so P0 again we will check. Again it is asking how much? 743 is the need, then available is 745. So now the condition is satisfied. So condition is satisfied. Now the safety sequence is updated with P0. So available is 745 plus allocated. So allocated is added. So we will get 7, 5 and 5. Then the P0 becomes true, means it has completed its work. Then you go to the second process and do again the available, compare the result, then add the allocated resource. So we will get 10, 5 and 7. So all the process has finished the work and safety sequence is P0, P1, P3, P4, P0 and P2. So this is the safe sequence means you allocate resources in this way for the process so that you can avoid a deadlock. Then there is a last one point where we will observe if you see 10, 5 and 7. So this actually where we started our problem where the available resources are 10, 5 and 7. So if it is matches means what we have done at the end of our safety algorithm, when we applied our safety algorithm to that system model and we are getting the correct result, so everything is matched, resources are also available as described earlier, and the safe sequence. So this is the safety sequence where the resources are allocated and uh, in this way. Okay, thank you.